Hello all, this is Harini from NRA Institute of Technology. Today my topic is about convex functions and non-convex functions. The contents are, first topic is convex function and second one is finding maximum and minima and third one is gradient descent, next one non-convex function and last one is difference between maxima and global minima. Before going to the convex function, we need to know about convex set. Convex set means any line joining 2 points is within the set or it is above the functional graph, then it is called as a convex set. If it is below the set, it is called as a non-convex set. Here, when the shape is regular, if you join any 2 points, if it lies within the convex set, then it is called as a convex set. Next, convex function. A function f of x is said to be a convex function if and only if its epigraph must be a convex set. That means the functional graph should be above the function. Epigraph. Epigraph is a set of points in the Cartesian product lying on or above its graph. That means all the points should be above the function graph. Then it is called as a convex function. Here there are some of the properties of the convex function. The first property is the shape of the convex function is U-shape. And the second property is the second derivative of the function should be non-negative, such that f double dash of x should be greater than 0. For example, when we take an example of y equal to x square, f dash of x equal to 2x. For f double dash of x, the derivative is 2. It is non-negative, it is greater than 0, such that it is non-negative, it is a convex function. For a strictly convex function, it has one local minimum point. The local minimum point is the global minimum point. And the sum of two convex functions is also a convex function. The function which satisfies all the above properties is called as a convex function. The next topic is finding maxima and minima. In order to find the maxima and minima of the function, first we need to derive the function f of x. And then we need to find the value of x at x equal to a. Then we need to equal the value of f of a to 0, such that f dash of a equal to 0. Next, we need to derive the function f dash of x and we need to check whether f double dash of a is greater than or equal to 0 or not. If it is greater than or equal to 0, f of a will be the minimum value of f of x. If it is less than or equal to 0, f double dash of a, it is the maximum value of the f of x. Next one is gradient descent. Gradient descent is the most commonly used optimization algorithm which is used in the machine learning models in order to minimize the errors in the cost function. The cost function is used in order to calculate the performance of a machine learning models. The cost with the use of iterative parameters, it will update the parameters and it will tune the parameters. With the help of this, we can find the local minima of a function. The gradient descent algorithm provides local minima of a function such that if we move towards a negative gradient or away from the gradient of the function at the current point, it will provide the local minima of that function. Whenever we move towards a positive gradient or towards the gradient of the function at the current point, then it will provide the local maxima of the function. In order to find out the gradient descent, we have two steps. First one is calculating the first order derivative of that function and we need to compute the slope of that function. The second step is we need to add alpha such that alpha is the learning rate. It should be the optimized value in order to provide us the local minimum point. The formula for the gradient descent is x equal to x minus alpha into derivative of f of x, where x is the input and alpha is the learning rate and dy by dx means it is the first order derivative of the function. The working of the gradient descent means here, whenever the learning rate is low, the learning rate will be the learning rate of the function. The learning rate of the function is minimum, and here the learning process of the model is slow. If the learning rate is very high, we will navigate and misuse and it will mismatch the local minimum point. If it is the optimized value, then we will reach the minimum point. Now, what is the cost function and what is the loss function? Loss function means whenever we use error for a single training example. That means if you take an error for a single term or single objective, then it is referred to as a loss function, cost function. Whenever we consider an error for the overall training data, then it is called as a cost function. The formula for the cost function is error equal to actual output minus predicted output. Why we need cost function? This cost function is used to find the performance of the machine learning model. Here, within the number of iterations, it will find the local minimum optimized value and helps us to find out the best machine learning model. Non-convex function. A function f is said to be a non-convex function if it is not convex. That means it has multiple peaks and valleys. The non-convex function has multiple local minima points and global minimum point and one global minimum point. In order to optimize the non-convex function, when we use the alpha as a learning rate, it will stuck at the local minima point, which will need not be necessary as a global minima point. So it is the major disadvantage in the non-convex functions. Difference between maxima and global minima. Global maxima means it is the absolute highest value of the function over its entire domain. And local minima means it is the lowest value in the entire domain. And local minima are the critical points where the derivative of the function is 0 or undefined. Thank you.